What is assembly language in microprocessor programming? Imagine talking directly to a microprocessor and telling it exactly what to do, step by step. That's what assembly language makes possible. Assembly language is a low-level programming language used to write instructions for microprocessors and microcontrollers. It acts as a bridge between the raw binary code that a processor understands and the more human-friendly languages like C or Python. At its core, assembly language uses mnemonic codes, short, simple words that stand for specific operations. For example, the instruction add tells the processor to add to numbers, while MOV moves data from one place to another. Each of these mnemonics directly maps to a machine code instruction, making assembly a near one-to-one match with what the processor actually does. Unlike high-level languages, assembly language is specific to each processor's architecture. Code written for an Intel x86 processor will not run on an ARM-based microcontroller without changes. Different processors have their own sets of instructions, registers, and ways to interact with memory and peripherals. Programming in assembly language gives electrical engineers precise control over hardware. They can manage processor registers, access specific memory locations directly, and control input and output devices. This control is essential when timing, efficiency, or hardware interaction is critical, such as in embedded systems or firmware. To create an assembly language program, engineers start by writing code in a text editor, saving it with extensions like ASM or S. Then, an assembler program converts this human-readable code into machine code that the processor can understand. The machine code is linked with other necessary code or libraries to form an executable file. This file is loaded into the processor's memory and run. Assembly language also includes directives, special commands that guide how the code is organized, how data is defined, or how memory is set up. Macros can be used to automate repetitive tasks, making writing and maintaining code easier. The main benefit of assembly language in microprocessor programming is the ability to optimize for speed and memory use. This is especially important in environments where resources are limited, like embedded systems. Engineers often write bootloaders, device drivers, or interrupt routines in assembly because of this level of control. However, programming in assembly language requires a solid understanding of the processor's architecture, including its instruction set, registers, and memory layout. Small mistakes can cause unpredictable behavior or system crashes. In summary, assembly language is a vital tool for electrical engineers working with microprocessors and embedded systems. It allows them to write efficient, hardware-specific code that interacts directly with the processor and peripherals. While it is more complex and less portable than high-level languages, its precision and control make it essential for many digital electronics applications.